Okay, so we have three equations to solve then, problem involving the meaning of slope, interpretation of slope, and the equation of the line. Most people didn't get to find the equation of the line, but I kind of tacked that onto the end. The main thing was get the slope, but then we will reinforce how you get that line, okay? And some of you actually got it, so that was very good. Okay, so let's say I've got 4x plus 7 equals 9x plus 12. What do I do? I want my x's on this side, I want my numbers on that side. I don't just move them. I do it by the rules. I do 4x plus 7 minus 7 equals 9x plus 12 minus 7. 7 minus 7 is 0. That's going to leave me 4x on this side. Now, if you're not doing that, you got to mark as this here. I really recommend that you get to the mark. Because you see me do this a number of times and somehow it's not taken. See how they explain it? Okay. But this is necessary. You have to be able to do this. Okay. Now, if you do this, minus 7 equals minus 7, and then add the things. I prefer to say it like this, but that's acceptable. Okay. But here we have it. Okay. So you got 4x is 9x plus 5. Now you subtract the 9x from both sides. And you end up with negative 5x equals 5. So in this case, negative 5x over negative 5 equals 5 over negative 5. So x equals negative 1. That's 5x over negative 5. So x equals negative 1. You plug this in. And I really don't see people plugging in and checking their work. Okay? And if you're making mistakes, which a lot of you are, if you're making mistakes, you really need to be checking your work so you know when you do a problem that you did something wrong so you can correct it. Okay? So I can't do that for you, but you really need to be doing that stuff. Okay, so you got x equals 1. You plug it back in here. For x here, and for x here. And that gives you 4 times negative 1 plus 7. Equals 9 times negative 1 plus 12. Negative 4 plus 7 equals negative 9 plus 12. 3 equals 3. And if it doesn't come out, you did something wrong. And you need to go back and fix it. Okay? Once more, 2 things you need to be doing. Number 1, if you're doing this by looking online and doing this and this, and it's just writing down what somebody tells you to do, you got to do that. It's okay. If you don't come back 2 days later and do it again without looking at anything, then you haven't learned. Okay? That's your test. And of course, your quizzes are your test. Most of you doing well, but some of you are not following this. Okay? If you're not following it, you're going to need to get that straight. Okay. And the markers there, they're great. You got great tutors. They can help you fix that. Okay? And some people are not doing this correctly, but they're doing the other stuff. That slow stuff. Looks great. Okay? That's actually much harder to comprehend than this. So it doesn't mean, it just means that there's something that you're not seeing that somebody is explaining to you differently than the way I do. Okay? So in that category, please follow my advice. And everybody should be checking most of their work. I know it takes extra time, but it doesn't take that long. and you learn far more. And you learn twice as much in an hour if you're checking things. So you end up spending less time to learn better results. Okay. So second equation, well, let's say we got 5 times x plus 7 equals 10 times 11x plus 5. Well, we have to use a distributive law. That means we got 5 times x plus 5 times 7, which is 10 times 11x plus 10 times 5. Okay. That gives us 5x plus 35 equals 110x plus 50. So now we have an equation just like this one, and we do all the same things. So I'm just going to write it down kind of quickly. Subtract 35 from both sides gives us 5x equals 110x plus 15. And then we subtract 110x. And we get negative 105x equals 15. We have negative 105x over negative 105 equals 15 over negative 105. So x equals negative 15 over 105. And of course, this reduces. And actually, 15 goes into 105 7 times. And from the assignments you've been doing in fractions, assume you understand that. If not, need a little more work on fractions. Okay? Can't really take time in class to teach you fractions. But most people need work on fractions, so make sure you're doing the work. Now the other one, okay. And I will read it. A little more general this one. Okay. Okay, what do we have to do? What's the common denominator here? 14. So we have 14 times x over 7. 14 times 3 halves equals 14 times 4. So every term is by 14. Multiply both sides of the equation by 14. Okay. Why do we do that? It's because this becomes 14 sevenths times x over 1. This becomes 14 halves times 3 over 1. And 14 times 4 is 56, of course. And 14 over 7 is 2. X over 1 is x. This gives us 2x. This gives us 7 times 3, which is I'll do another step and we'll split that, okay? Be real specific. So we get 2x plus 21 equals 56. And that's really easy to do. And now you don't have to deal with fractions and you can solve that almost instantly. Subtract 21 from both sides, you get 35 over there, divide by 2. Okay. Then you plug this back in up here and see if it works. Deal with fractions. It's something you love to do. Okay. Okay. If you're not multiplying your common denominator by both sides, you're making a mistake. Okay. You're going to need to get in the habit of multiplying by your common denominator for two reasons. One, it makes the equation much easier to solve, and that's much to your advantage. And the other thing is, you're not going to have any choice about doing that when you get into some of the rational expressions that come up around the third chapter. Okay. I'm going to have to do with symbols. So you want to get used to it now. All right. So on the whole, this is the only big problem I saw on more than one or two papers. Okay. You didn't multiply by common denominator. The only guy in my MDE 60 class who just doesn't mind working with fractions. You know, he seems to be able to solve these things with fractions, keep them straight, and do all that difficult fraction stuff and get the right answer. He just prefers to work with fractions. Okay. That's kind of impressive. Okay. Hang on, there we go. Now, this problem, first of all, and people get pretty well on this, okay? Now, one thing that about half the class seems to have done, though, is they put the time on this axis and the number of miles on this axis. Okay. Now, that's not a convention. Okay. Y versus X means that Y goes here and X goes here, right? So the one in front of the verses goes up here and the one after the verses goes there. All right. So you want to get that straight. Otherwise, you're not going to have it straight. You're going to get good stuff, but it's not going to be the same stuff. Okay. Turns out you would get an equation if you did time up here, okay, and miles down here. Okay. So if you put t up here and y down here, if you then solve the equation that you get for y, you would get the equation that you would get if you'd have done y versus t. It's going to be equivalent, in other words. It's not going to be the same. So I'll put y up here, and I'll call this x. And label the units on these things so you know that this is miles, that's hours. Okay. And then you realize that you label it wrong, so you go back and label it right. Okay. Y is a number of miles. And we're going to use t, which is in hours. Okay, so t has to go at least from 2 to 5, right? So I'm going to put 8 here. No reason you should. If you put 5 there, it's fine. That's kind of what I'd expect you to do. But actually, I'm going to then ask the question, well, where would we be after 8 hours if we moved at the same rate? So we use this to see how we apply the whole idea of linear equation and what it tells us. So I'm gonna put 8 here because 8's easy to subdivide and allows us to extrapolate a little bit. Not a perfect scaling, but it'll work. Then we got 308. Okay, well, I'm gonna go ahead and put 400 up. Now, if I was really being careful, I put a number bigger than 400. If I extrapolate out to 8, I'm probably going to get something more than 400, but that's okay. Now, we put our information on here, and you'll do well with this, okay? But you make sure that you're labeling the axes with what they should be. And now, after 2 hours, we're at 308 miles. And after, so 138 miles, sorry. So 138 would be about here. 2 hours is about here. Now, it's a good idea to label this point. So I'll just label it with the numbers because I know what units are with the numbers, okay? I know this means 2 hours because it's this coordinate, which is measured in hours. I know this is 138 miles because it's this coordinate and y scaled in miles, right? So that's the meaning. Okay, well, we got the 5 and we have 308, 5 hours, we went 308 miles. So 308 is about here. 5 is about here. Okay, so we've got 5, 308. You want to get all the information on your graph, so you don't have to keep looking back at what things mean. Okay, as I say, I think everybody was good on that. Okay, one person didn't get to it, but I'm sure you could have done it. Now we want to know what the slope is between these points. Now, really, I should say the slope of the line segment connecting the points, but we know what we mean by the slope between the points. Okay, so everybody knows that terminology. So I can draw the line segment between the points. I can draw my right triangle. One side parallel to the p-axis, another side parallel to this axis. Be careful. I'm going to label the direction from one point to the next. So we're going from this point to this point. So both of these paths lead us from this point to this point. Okay. If this arrow is in the opposite direction, then it would lead us from here to here, whereas these arrows lead us from here to here, and they lead us around in a circle. Would be a good thing. Okay. So we want to get those arrows right, so we know what our direction is, so we don't make a mistake. When you have a negative slope, it's easy to make a mistake, and it's important to do this. Then we can say that the run equals 5 minus 2, which is 3. And the rise is 308 minus 138, which is 170. Okay. So the slope is 308 over 170. Now that can be reduced. There it is in the raw numbers, okay? Well, it's not 308 over 170, it's 170 over 5, 170 over 3. I don't know. how I wrote that down, except that I do have this annual experience almost every year, sometime in February. I get overcome by brain fog. Okay. And I had a really bad case of it over the weekend. A little better today, but it didn't prevent me from doing that. Okay. And it's interesting. My swimming times go down, which means I'm swimming faster. Okay. My brain fog goes up. So there's some kind of conservation law there where the sum of these two things stays the same. It's a trade-off. I don't know what's going on. You'd think that if something bad is happening to my mind, something bad would happen to my body, right? That kind of thing. Anyhow, I'm going to swim today. If I don't drown, I'll see you next time. Okay. The swim was 170 over 3. You know, brain fog could get you in trouble if you're swimming. You know, you're trying to swim to shore and you swim out in the ocean away from shore. Okay, well, that's neither here nor there. But that's not one of the mistakes. Okay, so now we see the slope. Two 170 over 3, right? And that's what? That's 56 2/3 if you want to do it. Again, if brain fog didn't cause me to calculate that incorrectly, I think it's called that. Yeah, that's right. Okay. Meaning, what? How do you get the meaning? You put the units of these things and ask you what that could mean. And then you look at the problem and say, oh yeah, that's what it meant. Okay, so this is $170 miles divided by 3 hours. Okay. And if you do calculation, what's that mean? That means your average speed is 56 miles per hour, right? So we can say that the average rate of change again, a little loose for terminology, it should be displacement. Is 56 2/3 miles per hour. Okay. 4. Yeah, I'm traveling up the interstate, which I'm doing on Thursday. Okay. Then it's not a bad average speed if I've made a stop. If I travel at that speed the whole time, I'll get run off the road. Okay. But I'm more inclined to run other people off the road anyway. Unfortunately, I'm not driving the Dodge Ram, I'm driving a Toyota Corolla. Other trips I've made have been with a Dodge Ram, and you really do have a realistic possibility of driving most other drivers off the road, except tractor trailers and even bigger trucks, right? And Toyota Corolla, you got to kind of be a little more modest. But really, I don't drive aggressively, except against people who are driving aggressively. Okay, I don't tolerate that well, and I really should, because the reflexes feels like they're fine, but I know they aren't what they should be. Okay. Okay, well, so hopefully I'll use a little common sense, but the whole problem, the whole point is, number one, remind you I won't be here Thursday. Okay. We'll have class. And I think I did say that I wouldn't be here for this Thursday and the next one, but I will be here that following Thursday. So my wife has to have some minor surgery, but it has to be done right, so we're doing it at UVA. Just outpatient stuff, it's not a big deal, except the result needs to be right. She kept telling me her surgeon didn't do surgery on Friday, which I guess is usually true, but not this time. So that's why I said Thursday. Not blaming it on her. It was a reasonable assumption. We finally had the good common sense to actually look at the schedule for the one in the first place. So I shouldn't have confused you about the Thursdays. Okay. Anyhow, there we have it. It's an average rate of change. And now we can use it to get an equation. It tells us, well, if we keep traveling at that average speed, we know how long it takes to get any place until we run out of interstate. So a lot of these words weren't visible on the screen. But if there's a problem, that is pretty clear from what we've done. Okay, so now we can see the whole screen. Okay, equation of one. Okay, we're using t instead of x, time instead of whatever x might stand for, but it's the same idea as y equals mx plus b, right? Okay, well, m is 56 2/3, and I'm going to write this as 170 thirds rather than a mixed number. Mixed number gives us information, tells us how fast we're going. 170 over 3 is not as obvious, right? We can relate that to how fast we drive. And y equals 138 when t equals 2. Let's just use that. Y equals 138. And not actually t equals 2. So we have 138 equals 170 thirds times 2 plus b. That's easy to solve for b. Well, I don't want to deal with fractions. Multiply by a common denominator, there's only one denominator. And I get 324, which is 414, I think. Equals 340 plus 3b. So 3b I'm skipping steps here, don't skip steps. In this course, don't skip steps. You need to reinforce the steps so you know how to use them when things get confusing. For just an interest of time. And this, of course, is 74. So B equals 74 over 3, which is 24 2/3. Now the question to answer is, what's that mean? Huh? Okay, so. Y equals 173rd plus 74 thirds. Or assuming I did my arithmetic right, 56 and 2/3 t plus 24 and 2/3, meaning 56 and 2/3 miles per hour times t. So if I want to know where I'm after 8 hours, I multiply 56 and 2/3 miles per hour by 8 hours. And I find out what that is, right? Then I've got to add that to 24 and 2/3 miles. This is what the right-hand side of this equation tells you. It says multiply your number of miles per hour by your time, tells you how far you went. And then add that to this, which is where you would have started if you didn't have that 56 and 2/3 mile an hour average over the whole trip. Okay. So at the same rate, five hours. Okay, I don't want to say how far. I want to say where are we? After 7 hours. Well, if t equals 7 hours, then y equals 73rd times 7 plus 74 thirds, right? Meaning miles per hour times hours plus miles. And well, 170 thirds times 7 is 1190 over 3 plus 74 over 3, which is 1264 over 3, which is 421 and a third. So it'd be 421 and a third miles. Okay. Now that would be accurate if we're traveling at a constant speed. Since we speed up, slow down with traffic and make stops and stuff, my average speed for that 2 hours might be much higher. The traffic is smooth and I don't make any stops, I'm going to be driving at least 70 miles an hour. Otherwise, like I say, you get run off the road, especially if you're in a Toyota Corolla, somebody with a Dodge Ram will come up and run you off. Okay? Okay. I really like driving that Dodge real quick. Save the Dodge for other things. Okay, now I should have more board space. I'm not sure I do. I've got a lot more board space. Make sure I don't write too high on this board. Still focused. Miraculously, it looks like I am. Okay, well. So much fun with that. That's a huge amount of time. Let me see what's. Okay, we'll have an assignment due from what we go over today. Oh boy. We're really going to do that? Don't freeze up on me now. Okay. So what we want to look at, what I want to look at is in here. Let's see how far I can go on the screen. Okay, now we've done linear equations. So we need a little more work on linear equations. So we need to get operations straight, but most of you seem to do pretty good. Except for that thing about multiplying by common denominator. Get that in your head and get into that habit. Okay. Here's your standard form. And this is just your x squared function shifted h units horizontally, k units. Well, first of all, stretched by factor a, vertical direction, shifted h units in the horizontal, k units in the vertical direction. Don't mention that. Now that's a standard form of a quadratic function, out of a quadratic equation. Okay. Okay. Now, if I graph this thing, if I graph a quadratic function, the graph is going to have the same shape as your y equals x squared toolkit function. Okay, it's a parabola. It can be shifted, stretched, everything. So it's going to be somewhere. Might open upward, it might open downward, but if it opens upward, it might look like this. If I want this equation to have a y value, there are 2 points. The 2 x values that correspond for this given y. There are 2 x values, right? Now, let's put y down here. Show me with your fingers how many x values there are that give you that. Yeah, there aren't any. There's no point here that has the y coordinate down here, is there? Okay. So if this is your quadratic function and this is a corresponding equation for given y might be such that you don't have a solution. Okay. If you do have a solution, usually there are two of them, unless y is this value, right? Okay. So one solution for this y and no solution for this y value. Okay. Now, what's that have to do with this? Well, every solution is of this formula. It's called the quadratic formula. And notice that this square root contains a negative, a potentially negative term. So it could be that A and C are big enough that the negative 4AC makes this negative, right? If A and C are big enough for a given B, this is going to be negative. So it's possible that this is negative, and you can't do the square root of a negative. Actually, you can, but not with real numbers. You have to use complex numbers that we'll talk about later. Okay. So if b squared minus 4ac is negative, you don't have any solution. Because you can't do the square root of a negative number. And we've been over that. Okay. You can do it, but you don't get a real number. It's not, well, don't talk too much about real world because complex numbers have tremendous real world applications. But where you are right now, those solutions aren't going to be important for the applications we look at. Okay. And b squared minus 4ac 0, there's exactly one solution, right? And if it's greater than 0, well, the plus or minus, the plus gives us one solution, the minus gives us another. Okay, now I haven't completely connected this to the graph. We'll be talking about that a little bit later. So I wanted to show you the graph to show you if you have a parabola, you can have two x values for a given y value, exactly one. or none. Okay? That corresponds to these three cases. 2 in this case, 1 in this case, none in this case. So if this is a graph of y equals ax squared plus bx plus c, this is how you determine the x values to give you a y value. So let's just say the mechanics of how we use it. So if y equals 2x squared minus 6x plus 10, what value, let's say y equal to 15. The context in which you might use the formula. Well, you get 15 equals 2x squared minus 6x plus 10. That's not in this form, is it? In this form, you have equal to 0, right? So we have to subtract 5 from both sides, right? So we subtract 15 from both sides. So we get 2x squared minus 6x plus 10 minus 15 equals 15 minus 14. And that then gives us 2x squared plus 6x minus 5 equals 0. Okay. Now we can read off our solution. In this form, this is the form A, x squared plus bx plus c equals 0. You can see what A, B, and C are. A is what's the coefficient of x squared, right? That's 2. B is the coefficient of x, and it's minus 6. I'll put that down wrong. Coefficient of x is minus 6, and C is minus 5. Okay? So if you have an equation in this form, it's really easy. You just identify A, B, and C. Then hopefully you remember the formula. So y equals what? B is negative 6, right? So we have a negative of negative 6 plus or minus square root of negative 6 squared minus 4 times AC. Well, all we needed up to this point is B, but now we need A and C, so we look back and make sure A is 2, C is negative 5. So that's 4 times 2 times negative 5. And that's all over 2 times A. So we write 2 times A, which is 2 times 2. Well, then we do the rest. So negative and negative 6 is 6. The square root of this mess is, well, negative 6 squared is 36. And 4 times 5 times 2 is 40. That would be plus 40. All divided by 4. And that's 6 plus or minus the square root of 76 divided by 4. Now at this point, you kind of got to go to decimal. You don't know how to calculate the square root of 76. Okay, I can estimate it. 8 squared is 64, 9 squared is 81. Okay, 76 is quite a bit closer to 81 than it is at 64, but not all that close. So I'm going to estimate this, but of course you would use your calculator. Let's say it's about 6 plus or minus 8.7 over 4. Okay, if this is the equation, if this is your ax squared plus bx plus c, this gives you two values of x, and I said y. Well, I could blame that brain fog, but who knows? Okay, so that's x, right? Because your solution is of the form x equals. The solution gives you your x value. I wrote a y equals here, so I just wrote a y equals here without noticing. So it's x. Make sure you make that correction. These are your x values. Okay. So I don't have room to write this, but I'll just bring it up here. X equals 6 plus or minus 8.7 over 4. Now, x doesn't really equal that. It's approximately equal to that. And it's especially uncertain because I estimated that in my head. Pretty sure it's not 8.7, it's 8.6 or 8.8. I think it's 8.7. Okay. Well, that's either 6 plus 8.7 over 4, or 6 minus 8.7 over 4. 6 plus 8.7 is 14.7 over 4, or negative 2.7 over 4. And you can approximate that as a decimal. That's about 3.7. Yeah. And that's about negative 0.7. 3.7 negative 0.7. Well, that bothered me. That's kind of what I got in my head. Okay. So it's not difficult to use this. The one thing you got to remember in solving a quadratic equation is if you don't have it equal to 0, you got to do simple steps to get 0. One thing you don't do, you don't try to get all the x's on one side and all the numbers on the other. It's not going to work. You're going to have an x squared and an x, and you can't combine them. Okay? So don't do that. Recognize when you have a quadratic equation and solve it appropriately. Don't try to use the tricks you use for linear equations, because you know the idea of putting your x's here and your numbers over here, it won't work. Okay, only works for linear equations. Okay.